1, the first chapter. And we're going to start off with some number sense. Specifically, place values through 100,000. Now we can write numbers in many different ways: words, digits, expanded form, which I'm going to show you and teach you. So let's make a place value chart of this number first. So this is ones, tens, hundreds, and this is also ones, tens, hundreds. So you may be wondering, what's the difference? Well, this is technically the thousands tab. i.e., in the thousands tab, you say just 7,000. This would be 30,000 because it's tens, and this would be 200,000. So the standard form is just the ones with the digits. In some countries, there's no comma. Sometimes it's just a space. And sometimes a comma is replaced by something different. But the word form differs with every single different country that has a different language, because the word form is written as you speak it. So in English, it would be 200, 30, 7,000, and 237,000, 5. Well, you want to write it all in words, so no digits. 500 and 68. Okay. Now that's long, but what about expanded form? Expanded form is when you take the place values and write it all out. So here it would be 200,000 plus 30,000 plus 7,000 plus 500 plus 60 plus 8. So now let's practice the long expanded form a little bit more by completing the expanded form of these two numbers. Now over here we have 80,000, and then the next one would be 7,000. And the next one is 500, and then it'd be 60. Over here it's 400,000, and then 30,000, 1,280, and 1. That's it. Complete the chart by filling in the missing forms. Well, we know that standard form, well, we know what it is, so we have expanded form to base it off of. Now we have 100,000, and then we have 20,000, which comes right after. But we have nothing in the thousands place. So what do? We put a 0. But we have something in the hundreds place, 600, so we put a 6 in the hundreds place. Don't forget the comma. And there's 40, and then 9. So what's the word form of this? Well, let's read it out. 120,649. Now notice that I added ands. Some teachers don't do that. Some people will say 120,649. Some people would say 120,649. The ands are just, well, it depends on who's teaching, who's marking, who's writing. there's not that much, that big and that valued of a rule. So I'll just do it my way. 120,000 and 600, and that's an ampersand, by the way, that's what it's called, the and sign. 49. Now that that question's done, we're going to move on to the next one, where we have the standard form, but there's no expanded form or word form. Well, the word form should be pleasant enough, because we just have to read it out. Now, how about the expanded form? Well, first we have 300,000 plus, there's now 30,000 plus 8,000. Some of you may be confused on why we use expanded form. Don't ask me. I don't know either. It's probably just for understanding purposes, but it's kind of weird. Like, why would you ever want to write it this way? 200 plus 30 plus 7. Word form. 300 38,000. Now you could choose and, but for this time I'm not gonna. 237. We move on. Now over here, again, we have the expanded form, but unfortunately, not the standard form or the word form. So let's work out the standard form. Well, first we have 500,000, then we have 10,000, then we have 3,000, comma, 461. Okay. The word form would be 500. Now you don't say 10,3,000. You just say 13. 13,000 461. Yay! We're going to move on to question number 6, which is also the last question of the section. Standard form, word form is actually what we get. Unfortunately, we don't get expanded form or standard form. 763,398. So we have 763,398. 398. Simple as that. The expanded form would have 700,063 thousand, 3,000, 300. There's no comma in the hundreds. 90, and then 8. You don't actually need a period. Now that we're done for the place values in the thousands, we're going to go to place values in the millions. Now the millions, it's the same principle. You have million, 10 million, and 100 million. And then you move on to another place value. This isn't like some languages where it's kind of confusing. In English, we have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, blank, 10 blank, 100 blank, blank number 2, 10 blank number 2, 100 blank number 2. It just goes something, 10 something, 100 something. That's English. That's all there is to it. Now what would a place value chart of this monstrosity be? Well, we have, it looks like there's million, 10 million, but there's no 100 million, so we're just gonna forget about that. 10 million, there's 1 million, there's 4 in the million place, then there's 100,000, which I'm just going to put as HT because it's a little long to write out here, 10,000, which is 5, normal thousands, 300s, 9, 10s, 8, and 1s, 7. That's all there is to it. So the standard form of this would just be, well, what's written up here. Now what about the word form? We have millions now. Now we don't say 10 4 millions, because that'd just be weird. And that sounds like there's 10 4 millions, which would be 40 million. Like what we do in the thousands, we say 14 millions. So the word form would be 14 million 100. Again, the ands are optional. You can put an and here. You could put an and here. 53,000. You can put an and here. 900. You could put an and here. 87. In general, there's a lot of ands that you can put. Different people have their different habits of anding. Now, expanded form. Well, we have 14 million, which is 10 million plus 4 million. And then we have 100,000. 50,000, 3,987, which is 80 plus 7. Yay! So we're going to do a similar complete the chart activity. Remember guys, you can pause the video at any time you want and take a break, do some practice problems, take a drink, go to the bathroom, eat some lunch, eat dinner, eat breakfast. Actually no, you should eat breakfast before you do this. Breakfast is an important meal of the day, kids. Now we're going to move on. We have the word form here, but we don't have the standard or expanded form. Now we could get the standard form and the expanded form from the word form, obviously, because we've done that for the thousands places. And the millions places really isn't all that different. So the standard form, we have 7,356,237. Yay! So the expanded form would have 7 million plus 300,000 plus 50,000 plus 6,000 plus 237, which is plus 30 plus 7. Yay! So we move on to, well, the next question, where we have the expanded form, but not the standard or word form. So in expanded form, we have 40 million, so there's a 4 up there now, and then we have 1 million. Then there's that, which is 600,000, 50,000, 9,000. Then we have 700, but we have nothing in the tens place, which means that we just put a 0, then 3. What would the word form of this be? Well, 41 million 600 59,000 703. Now I'm saying that I did say actually that the ands are optional usually. But when there's no tens place, or 10,000s place, or 10 millions place, or whatever, then there usually is an and. Say if there wasn't the 50, then there'd be 609,000. Usually we don't say 609,000, because that just sounds as if there's something missing. Now, we're going to move on to the last problem of this section. And we're going to move on to problem-solving strategies. Yay. Standard form is what we got. The rest of the stuff we have to find out. So let's do expanded form first. Well, for the standard form we have 200 million plus 30 million plus, then there's 5 million and over here we realize that we don't actually have anything in the hundred thousands place, so we skip it. and go on to 90,000 plus 1,000 plus 500 plus 60 plus 8. Now what's the word form for this? Well, we read it out. 235,091,568. Now I like using the and over there. Some people don't. And you guys could discover which one you prefer. 35,091,000 500. You know what? I'm not going to put any ands for this one. 68. Now that that's done, let's move on to the next section. Problem-solving strategy. The 4-step plan, i.e. what we have been doing for the past while. If you want to solve a problem, it is important to have a plan. You can use the 4-step plan to solve most problems. Wow, really? Use this exercise to learn more. This sounds like an advertisement. Mihail's? Yes, that's actually pronounced Mihail. It took me a few years to realize that, but I knew somebody in high school named Mihail. His class is having a picnic. We've had potlucks before, but not picnics. The class will make sandwiches at the picnic. There are 36 students in Mihail's class and 18 slices of bread in a loaf. How many loaves of bread will Mihail's class need for the picnic? Each sandwich will have 2 slices of bread. Understand. What do we know? What do we need to find out? So there's 36 students in the class, 18 slices of bread in a loaf. And each sandwich needs 2 slices of bread. And assuming that the teacher just doesn't eat a sandwich, that's all that we need to know. What do we have to find out? How many loaves of bread will the class need for the picnic? Step 2, plan. The best plan in a math class is always math. That's an A, by the way. That rhymed. Anyhow, now we solve. 36 children times 2 slices of bread. That's the amount of bread slices that we need to feed these 36 children. Is 72. 72 divided by 18 is the amount of loaves that we need to feed these children. Assuming that some people want the end pieces of a loaf. Because apparently, from what I've heard, a lot of people don't like the end pieces of a loaf. Personally, that's one of my favorite parts, so I'm not sure, I don't know why, but some people just don't like it. Anyhow, it's 4. 72 divided by 18 is equal to 4. Now, how can we check? Well, we could do it in reverse. 4 times 18 equals to 72. 72 divided by 2 is the amount of sandwiches that could be made, and that's 36. Therefore, our answer is reasonable and it is correct. Now, we're going to solve these questions using the 4-step plan. There are 30 students who want to play in a basketball tournament. The tournament needs 1 game ball for every 2 teams. If each team will have 5 players, how many basketballs will the tournament need? Well, we have 30 divided by 5 teams, which is 6 teams. And we need 1 game ball for every 2 teams, so 6 divided by 2 is equal to 3. We need 3 basketballs. How do we check our answer? 3 times 2 equals to the number of teams, which is 6. 6 times 5 equals to the number of players, which is 30. Done. We're going to move on. Josh and Anthony have a lemonade stand. Cool. They sell 2 glasses of lemonade for $1. I mean, that would be a bargain, but if the glasses are this small, then it wouldn't. They sell 14 glasses each afternoon. I hope they mean a mean or average of 14 glasses, because, well, if you sell exactly 14 glasses each afternoon, that'd be a very unlikely coincidence. How much money do Josh and Anthony make after 3 days of selling lemonade? Well, what do we know? They sell 2 glasses of lemonade for $1. They sell 14 glasses each afternoon. What do we need to know? How much money do they make after 3 days of selling lemonade? Well, what's our plan now? Math! So let's carry out our plan and solve it. Yay! Now, 14 glasses each afternoon, 2 glasses for $1, which means that 14 divided by 2 equals the amount of money they earn each afternoon, which is $7. So 3 days of selling lemonade, 3 times 7 equals to 21. Yay! Check. How do we check? Well, 21 divided by 3 equals to well, not technically profit, the amount of money they earned for 1 day. And that's 7. 7 times 2 equals the amount of glasses they sold, which is 14. So that corresponds with the facts. Therefore, our answer is very most likely correct. Unless there's something wrong with the problem and answers. They will make $21. Jessica can ride her bike 3 blocks in 1 minute. It takes her twice as long to ride her bike 3 blocks if she carries her backpack. It's riding a bike, not walking, but okay then, I guess. If her school is 12 blocks from her house, how long will it take to get to school with a full backpack? Assuming that it takes her twice as long with a full backpack, because who knows, the teacher might try to trick you and go like, that's an empty backpack. Full backpack actually takes 3 times as long. But like, I mean, they might do that actually. But we're gonna assume. So she's carrying a backpack. We know that. Her school is 12 blocks from her house. We know that. And she can ride her bike 3 blocks in 1 minute. We know that. But if she has a backpack, then it takes her twice as long. We also know that. So what don't we know? How long will it take to get her school with a full backpack? Well, what's our plan? Math! Let's carry out our plan and solve it. And ignore my insanity a few seconds prior. So how long would it take for her to ride 3 blocks with a backpack? Twice as long. So what's 2 times 1 minute? 2 minutes. Which means that she can travel 3 blocks in 2 minutes if she has a backpack. Her school is 12 blocks, which means that it's 12 divided by 3, which is 4. So 4 times 2 minutes equals, well, it would be 4 2 minutes because there's 4 3 blocks. So that'd be 8 minutes. Check. Well, 8 divided by 2 is 4. 4 times 3 equals to 12. Amount of blocks is correct. The speed, well, time it takes to go that distance, which is technically just speed, but is also correct. And everything that we know is correct. The answer seems reasonable, so we can move on. A group of friends needs to carry a large basket of books to the library. Why? Kevin can carry the baskets 5 feet. Rachel can carry it 3 feet further than Kevin. Hang on. 3 feet is like maybe this long. How big is that basket? And if it's that heavy to carry, you might as well just put it on the ground and push it. Or kick it, but okay, it's a math textbook. The one place where somebody can eat 120 candies in one go and nobody would say anything. So I'm just gonna ignore that. Daniel can carry the basket half as far as Rachel. 1.5 feet. That's weak. If each friend carries the basket 3 times, how far will they move the basket? What do we know? We know how far everybody can carry the basket. And we also know that the question is asking us how far 3 times that distance would be. Now, what do we do? Do you even have to ask math? So now we solve. Step 3. So we know that if everybody carries it 1 time, it'd be 5 plus 3 plus 3 divided by 2, which is 1.5. So that's 9.5 feet. And each friend carries the basket 3 times. So 9.5 times 3 equals to 28.5. As for checking like a checking account at the bank, but okay, I'll stop with the bad puns. Well, we got our facts correct. There's 5 feet, 3 feet, and half of Rachel, which is 3, so half of 3. And we did the addition correctly. They said everybody does it 3 times. So we also did the multiplication over here. Let's see. Yeah, we did it correctly. So our logic is sound, our facts are straight, and our calculations are not wrong. Therefore, it's almost impossible for the question to be wrong, unless it's a trick question, and it says, oh, each friend carries the basket 3 times, but we don't count the amount of times they kicked it onto the floor. But it should be correct. Now we're going to move on to section number 4. Remember, guys, you can take a break anytime you want. Comparing numbers. Yay! Why do we compare numbers? To figure out which one's bigger. Remember doing the basics of this back in like grade 2? Math? Over here? Yeah. Compare 12,572 and 15,572. So on the number line, if it's more to the left, then it's smaller. So that means that 12,572 is smaller than 15,572. And the smaller than sign is, well, this. Now we could do it with a place value chart instead. Or we could do it just in our head, mentally. Which is almost like a place value chart, but really you don't have to draw the chart out. So we line everything up, and then we realize that everything's the same except, well, here. So when you look at the difference, whichever one's bigger, well, then it's a bigger number. So the number 15,572 has more thousands than 12,572. Now the way that you do it in your head is just, it's basically a place value chart, except you don't actually look at the chart, or you don't actually create a chart in the first place. So you look at the two numbers, and then you go from left to right on both numbers. And you keep moving until there's something different. And once there's something different, you just ignore everything to the right of that something different and compare which one is bigger. So for this, it'd be, oh, 1's the same, but 5 and 2 aren't. We completely forget about these guys. And then we realize that 5 is bigger than 2, therefore this number is bigger than this number. Yay. Much faster, you don't have to draw anything. I mean, I like drawing, but like doing this just for the fun of it, no. Compare. Use the signs. So let's use our method. So 4, the same, 2, the same, 6, the same, 1 and 3 are different, and 3 is bigger. Therefore, this one's bigger. Question number 2, 1's the same, 3 is the same, 9 and 8 are not the same, 9 is bigger. Therefore, this is bigger. 4 is the same, 2 and 7 are not the same, 7 is bigger, so therefore, the one with the 7 is bigger. 8 is the same, and 7 and 0 are not the same. So, the one with the 7 is bigger, because 7 is bigger than 0. Of course, you might realize that 97 is bigger than 90, but this thing has 700 on top of it. 90 doesn't do anything. Well, 7 doesn't do anything. Compared to 700? No. So over here, 7 and 7 the same, 1 and 1 the same, 8 and 2 are different, 8 is bigger than 2, so the one with the 8 is bigger. 5 and 5 are the same, 8 and 0 are not the same, and 8 is bigger, so this one's bigger. Well, the one with the 8 is bigger. Now, if you don't remember, for these signs, the wider bit points towards the bigger one, or the point is pointing towards the smaller one. Most people describe it as a mouse that's trying to eat the bigger one because it wants to eat more. But let's move on. 1 and 1 are the same, 1 and 0 are not. 1 is bigger than 0, so therefore the one with the 1 is bigger. Here, 1 and 1, 3 and 3, 7 and 7, 7 and 8. 8 is bigger than 7, so the one with the 8 is bigger. 6 and 6, 5 and 5, 9 and 9, 8 and 8, 7 and 7. Everything is equal, so it's equal. 8 and 8, 1 and 1, 0 and 9. 9 is bigger than 0. I know that these two numbers are made out of the same combination of numbers, but, well, this happens. 1 and 1, 2 and 2, 4 and 4, 6 and 7. Now, 6 and 7. Which one's bigger? 7. So the one with the 7 in the hundreds place is bigger. 2 and 2, 4 and 4, 5 and 7. 7 is bigger than 5. So the one with the 7 in the thousands place this time, it's the thousands place this time, is, well, bigger. 7 and 7, 1 and 1, 8 and 9. 9 is bigger than 8. So the one with the 9 in the thousands place is bigger. 3 and 3, 8 and 7, 8 is bigger. So the one with the 8 in the hundred thousands place is bigger. Now we move on to ordering whole numbers, which is like, well, comparing whole numbers, except that you have to put them in order. Remember, guys, you can take a break whenever you want. Order the numbers from least to greatest. 9,245, 6,082, 8,970, 5,329. Okay, you can use a number line, or you can use a place value chart, or you could just compare. But let's do the place value chart. I'm not actually going to write the place values because a place value chart is just lining them all up. The leftmost digit, which is, well, the thousands in this case, are all different. So we just order them by the greatness, largeness, by how big the thousand is. So that would be we end up with the same order that the number line gave us. Except we didn't actually have to draw that much. And in case you haven't noticed, drawing a straight number line with equal divisions is actually harder than it looks. But the thing is, right now, we realize that it's supposed to be greatest to least. And now it's least to greatest. So what do? We just flip it around. Done. So now we're going to do some of these exercises. Well, 3 of them, actually. So here's how I do it. I kind of do the place value thing, except I don't draw anything. Just like I do when comparing numbers. So, they all have 1,000 as their leftmost digit. So we can't really judge anything from that. Then we go on to the next leftmost digit, which is the hundreds place. And they all have different hundreds place. So that's how we're going to judge. Now, out of the hundreds places, there's 1, 4, 5, and 2. And if we order 1, 4, 5, 2 from greatest to least, it would be 5, 4, 2, 1. So that's how it's going to go. The one with the 5 in the hundreds place comes first, then the one with the 4, then the one with the 2, and then the one with the 1. Same goes over here, except we realize that, well, there's 2 different values for the thousands place, or the leftmost digit. 4 and 5. So from 4 and 5, we know that 5 is bigger than 4, so these 2 are the greater 2, and these 2 are the not as great 2. But what do we do after? Well, we compare the hundreds place in these 2 groups. There's no need to compare the ones from the 5,000s with the 4,000s. Because it's already established that if you're in the 5,000s range, you're greater than the 4,000s range. Now, 7 and 1. 7 is bigger than 1, so we have our winner. And second place is the 5,000 with the 100. Now we have the 4,000s. So the 4,000s, there's one with 300 and there's one with 200. And 300 is bigger than 200, so. Ta-da! And over here we have a case of, well, not everything. The leftmost digit is at the same place value. because this is 10,000, and these are just thousands. Well, these are just thousands, that's 100. These are just thousands. So obviously the 10,000 one is biggest, or greatest, so that's our winner. And since the rest of them are all different anyways, 987. As simple as that. Done. So we go to rounding whole numbers. Now, I'm sure we've talked about rounding before, sometime. So here's how you round. You could put it on a place value chart or a number line, as shown over here, and see what it's closest to. Or you could use the expanded form and see that. Look at that. But that's not necessarily the case, especially for things like this. So here's how you actually round. Let's use this as an example. So it says we're supposed to round it to the nearest 100. So we locate the hundreds place, which is this one, 6, and we go one place to the right, 5. And if the digit is 5 or more, we round up. If it's anything less than 5, like if it's 4 or 3 or 2 or 1 or 0, we round down. So then over here it's 5, so we're going to round up. Now, what's upwards of 600? 700. Over here we have another round to 100. But when we go one place to the right, it's a 4, which means that we will round down. Now we don't round downwards of 800, which would be 700. We just round to 800. Here we're going to round to the thousands place. And if we go one place value to the right, that'd be the hundreds. Now here the hundreds place is a 1, which means that we round down to 2,000. Over here, we're still rounding to the thousands, except with a different number. The hundreds place is 8, which means that we will end up rounding to, well, 800, because upwards of 7 is 8, and 8 is bigger than 5, so, well, we're going to round up. Simple as that. Question number 5, we're rounding to 10,000. So if we move one digit to the right, we're going to go to the thousands, and for the thousands place, it's a 5, and 5, we round up. That'd be 20,000. Over here, it's the same thing. We were rounding to 10,000, well, the nearest 10,000, and the thousands place is less than 5. So we're going to round down to just plain 30,000. We're going to start rounding to 100,000 here. Now, if we move one place to the right, it'd be 10,000. So, the 10,000 place is 4. 4 is less than 5. We're going to round down to just plain 200,000. Over here, the 10,000 place is 8, which means that we'll be rounding up to 700,000. Now, question number 9. The 100,000 digit exists, but, well, we're rounding to the 10,000s. Now, how are we going to do that? Well, simple. We just ignore the 100,000. And what's in the thousands place? 7. So we're going to round up. But we're rounding up to 10,000. So we're not going to change anything in the 100,000s. We're just going to change the 10,000 digit. So instead of 537,000, it'd just be 540,000. Over here, it's the same scenario as the one before. But here, we're going to round down. We're not going to round down all the way to 200,000 because we're not rounding to the nearest 100,000. We're rounding to the nearest 10,000, which would be 270,000. Now we have the millions place, but we're rounding to the thousands. So we're not going to actually look at anything over here, but we're just going to look at the hundreds place. So the hundreds place is a 6, which means that we'll be rounding up. Well, we're going to round the thousands up. So it'd be 2,764,000. Over here, we're still rounding to the thousands place, and it's still there's the millions place still exists. It's 6 million this time though. So the hundreds place is a 6, which means we'll be rounding up again. And upwards of 0 is 1. Which means that we get 6,381,000. Problem solving. Again! You're probably going to get 2 of these every chapter, guys. Get used to it. Sometimes you can solve a problem using more than one strategy. Wow! Amazing, right? It's not that amazing. You must choose a strategy that works best for you. I mean, I know some people that like to draw things out and, well, it helps them. But by choosing the best strategy, sometimes it's choosing the more simple, sometimes it's choosing the less space consuming, sometimes it's choosing the less time consuming, and sometimes it's choosing one that you actually understand. Use this problem to learn more about choosing a strategy. Sam has 3 shirts to give to his friends. Each friend has one favorite color that is either red, blue, or green. Michelle does not like red or green. Ben does not like blue or red. Lindsay likes red. Who likes green? So what do we know? We know that each friend has a favorite color that's either red, blue, or green. And we know that, well, we just know which colors everybody likes or dislikes. So what do we have to find out? Who likes green? Choose a strategy. We could do logical reasoning. Or we could make a diagram, act it out, draw it out, make a chart. So for logical reasoning, we would go, Ben does not like blue or red. That's just, there's only green left. So Ben likes green. For drawing a chart, we'd have something like, well, red, blue, green, Michelle, Ben, Lindsay. And then Ben does not like red or blue. Michelle does not like red or green. Lindsay likes red. You could also act it out with friends, but, well, yeah. So personally, I would choose logical reasoning because it's quicker and I don't need to draw things. But either way, you get the same answer that Ben is the one that likes green. So if you have multiple answers that were solved or created using different strategies, chances are, if those answers are all the same, chances are your answer is correct. It's like that thing where people ask you, you know those relatable posts? Yeah, those, where one person is, my classmates arguing about whether or not the answer to the last question on the test was 438 or 436. Meanwhile, I got 3. Yeah, you're either it's either everybody else is wrong or you're wrong. chances are it's probably the second one. Now, we can use any strategy shown below to solve. Tell which one you used. Okay. This one is a bit of a foreign name, so excuse me if I mispronounce it. Alejandro collected bugs for a science project. He has a painted lady butterfly, a monarch butterfly, I hope he's keeping these guys alive, a bumblebee, a lime butterfly, a honeybee. How did he catch a honeybee without getting stung? A speckled wood butterfly, a carpenter bee. Okay, how did he catch a carpenter bee without getting stung? And a plum Judy butterfly. Did he collect more bees or butterflies? Well, let's just use a four-step plan, because use a four-step plan is just another fancy way of saying do whatever you want. Why? Because, well, if you think about it, choosing the plan is the second step of the four-step plan. So, the four-step plan. 1 butterfly, 2 butterfly, 3 butterfly, 4 butterfly, 5 butterfly. Bees, 1 bee, 2 bee, 3 bee. To be or not to be. So there's obviously more butterflies than bees. You could also do a simple diagram such as circles for butterflies and lines for bees. So circle, circle, line, circle, line, circle, line, circle. So there's more circles. You could also make a chart or table and do a tally. But your general conclusion would be he collected more butterflies. Now we move on. Isaiah is growing his dog walking business. The first week he walked 1 dog. The second week he walked 2 dogs. The third week he walked 3 dogs. If this pattern continues, how many dogs will Isaiah walk in the 7th week? So that would be, look for a pattern. So the pattern is number of dogs walked equals to week number. So if the pattern continues, then the 7th week would equal to 7 dogs. He will walk 7 dogs. Carlos lives 2 blocks west of Kimberly. Elizabeth lives 2 blocks east of Kimberly. How far does Elizabeth live from Carlos? Here we could draw a diagram technically. So let's say Kimberly. And then Elizabeth's east would be never eat shredded wheat, so 2. And then Carlos lives 2 blocks west. So 2 plus 2 equals to, well, 4. She lives 4 blocks away from Carlos. Excuse the C here. Kelly earns $5 every time she washes her neighbor's car. How many times will she need to wash the car to earn $45? Let's use a 4-step plan for this because honestly this is just math. Because 45 divided by 5 equals to 9. we forgot something, because sometimes you don't have to read, well, you don't just have to read the instructions for the question. You have to read the instruction at the top of the page, which is tell which one you used. Now over here, we used basically everything. Basically all of them. Now here, we did find a pattern. Here, it's draw a diagram. Is that one of them up there? Draw a picture. Picture. Draw a picture. And here we just did, we're just going to call it the 4-step plan. Technically, we just planned it as math. That's it. We're done the chapter. And we're done the place values for the chapter and the problem solving. And we're just done the chapter in general. So, I guess I'll see you next chapter.